record also. Okay, for kinematic of rigid body, who can tell me how many types of kinematics of rigid body? How many types of kinematics of rigid body? Type of rigid body motion. How many types? How many types? Rigid body motion. It has 3 types. Yes, very good, Irene. Has 3 types. What are they? What are they? 3 types. Correct. It's 3 types. What are they? Okay. First one is the translation, right? This is translation. That's good one. And rotation about fixed axis, right? And then it is general plane motion. That's good. That's good. That's good one. That's good job. Okay. So now you know already it has 3 types. Okay. So let's consider this system. Let's consider this system. Okay. If we consider the motion of crank OA, motion of crank OA. Crank OA is what? Crank OA. It's over here, right? It's crank OA. Okay. Motion of crank OA is what? Form T type. What is that type? What's that? Crank OA is what? Crank OA. The motion of crank OA is what? Motion of crank OA is general plane motion. Are you sure? You're not sure, right? So another one. Crank OA. We're talking about OA. So then we have to define first what is the translation is. What's the translation is? Translation. We have the body, right? Okay. For translation is mean that it just move the body is moving maybe like this. This is point A, this is point B. Oh, sorry. Point A. Okay, this is point B. So it's maybe rectilinear motion like this. This is translation. So the motion is maybe the straight line, or it's maybe the curve. Okay, it's maybe has the motion is maybe like a curve. That's also, but it is a translation also, right? Okay. For translation, what is a key point? This is the velocity of any point on the body. It should be equivalent, right? Okay, that is the key point. It is a translation. Okay, and after that we have the rotation about fixed axis, right? This is maybe half one point fixed. Okay, and we have the body like this. So it may rotate about this axis. So the motion along the point on the body is maybe like the circular motion, right? This is the body is maybe moving like this. Okay. But if we're talking about the general plane motion is mean that it's mixed between translation and rotation. It's a mix between of this. So that means that if we consider AB again, but now AB is just not like just not only translate, it has rotation also. So it means that it's maybe moving like this. Okay, so it translates also because it has moving to another point. and it has the rotation also. So this means that the block AB from the position 1 to position 2, it has the translation and also the rotation. This means that it is the general plane motion. Okay. So then consider this again. For crank OA, it is what? Irene. Again, please. Irene. What is it? Okay, so crank OA should be the rotation, right? About fixed axis. Okay. So crank OA should be rotation about fixed axis because it has just rotation. It has no motion. It has no translation of crank OA. It has just rotation, rotate about point O only. Okay, the fixed point is O. Okay, for AB. How about AB? What is that? If we consider AB, AB is what? AB is what? AB is become general plane, right? It's become general plane motion. So why it's become general plane motion? Because after if we consider this, okay, when OA is maybe moving like this, okay, AB is maybe something like this, right? Okay, so that means AB is moving from this shape to be this instead. Okay, so is change the position and it also has the rotation also. It has the translation and rotation. So then mean that link AB is become general plane motion, right? Okay, so if we just focus on the block B, just leave for the block B, piston B over here. What is this type? What's this type? For block B, for piston B, is what? For piston B is what? Okay, it's become the translation, right? Okay, it's become just translation. And if you would like to give more detail, it's maybe rectilinear translation. That is the piston B is moving along the straight path, as we may call rectilinear translation. But if the block B is moving along the curved path, we call the curvilinear translation. Okay, that's but translation is just okay. Just only translations maybe okay, like that. Okay, so now we already know what type of this system, what type of each part motion. Okay, for this system is composed of 3 parts. So when we separate the motion for each part and we understand that it has the different type of motion. Okay, so then now we may have to start to solve this problem. Okay, to solve this problem, actually we have, as you have learned from the material, you see that we can solve the general plane motion. We can solve the kinematics of rigid body by using many ways. First method that is we may apply, that is the relative velocity and relative acceleration method. Okay, we can consider the relative motion of any point. Okay, and then we can solve by using the relative motion. Okay, and the second one, we can apply the absolute motion also. And the last one, we may use the advantage of the point of instantaneous point of zero velocity to help us to solve some problem. This is maybe help us to for some part that is maybe easy to find the velocity and angular velocity for that case. Okay, so then let's we consider this. Okay, and we may apply the relative velocity method to solve this problem. How should we start for this problem? You can tell me. How should we start? Should we start? Okay, so this problem we may starting with first thing that we have to do. We have to set up the coordinate system. Okay, so we may analyze the problem first. Describe the type of motion we already done, right? Okay, and for this system, it's defined that plank OA rotate with the angular velocity omega OA. Okay, we have omega OA already. It's 12 radian per second. Okay, 12 radian per second in that direction, in the direction that is counterclockwise. Okay, we would like to find the velocity of piston B. We would like to find VB. VB is equal to what? We don't know, right? And the angular velocity of log AB at the instant show. Okay, at this instant. Okay, at the instant show, it means that at the angle equal OA is 90 degrees, right? And angle theta we can determine, right? Because we have this length. Okay, so for this, what is angle theta? We can determine first. Okay, angle theta is what? Angle theta. Okay, so we may starting with sine theta, right? Sine theta is equal to 0.8 divided by 1, right? So theta is become arc sine, okay? 0.8 over 1. Okay, so what is that? Okay, so then you can solve it by yourself, right? Okay. Okay, if you have to know the angle theta for that case. And we know the angular velocity omega OA of plank OA. We would like to find the velocity of log AB. So then how should we start? Because we know omega of OA, we have to consider the motion of OA first. We may starting with OA, that we know the information, right? Okay, from OA is what? This is rotation about fixed axis, right? It's rotation about fixed axis. As it's moved to the right, that is the omega OA is counterclockwise. So then we have to set up the coordinate system. That's we may set up the coordinate at the fixed point that we know. This is the reference. We should set up the reference at the fixed point. Point O is the fixed point, right? So then we may set up the coordinate maybe like this. This is X, this is Y. All right. Okay. We may starting with set up the coordinate system X and Y like this. Okay. So then we may consider just only part OA first. Okay, let's consider the motion of OA. Okay, set up the coordinate. It's X, oh sorry, it's X, Y. Okay, and OA, we have omega OA over here equal to 12, right? Okay, equal to 12. So then let's define the coordinate. It's 12 radian per second omega OA in this direction. So for the right hand rule, what does it mean? If we set up the coordinate like this, it's x, it's y, right? X, Y, C. So C direction should be over here, right? Okay, C direction is over here. So then let's set up the thumbs. Your thumbs. Okay, put your thumb to the C direction. So then what does it mean? You see that omega, the positive direction, it should be like this. Okay, so that means if we write omega OA in vector, it's become 12k, right? You're right. You're right. Okay, so omega OA is 12k. This is in direction of k. This is positive k direction. Are you all right? And after that, we set up the left length over here. Okay, this point O, this point A. So then, from this, we can imagine that the velocity VA should be like this, right? VA. Okay, according to the rotation about fixed axis. For rotation about fixed axis, if we consider clamp OA. So how can we find the velocity at point A? Okay, we know that omega OA from this, when we set up the coordinate system already, omega OA is what? It is 12k, like this. Okay, and then what is ROA? Okay, this is a reference, right? This is the reference. So then ROA is like this. Like this, it's moving here. Okay, ROA. We have ROA. ROA is we call it set up the axis XY like this. Okay, so ROA is what? ROA is over here. Draw the line. This. Okay, this is ROA. Right? ROA is what? From the picture, we know that it is 0.8, right? Okay, so ROA is 0.8 XY, so it's J, right? Positive J. Okay, to this point, do you have any question? First, you all right? Then we would like to find velocity of point A. For velocity of point A, because it is a rotation about fixed axis, right? So velocity of point A is very easy to find. That is what? It is VA is equal to omega OA cross product with ROA. Right? Okay. Okay. You understand that? Okay. So it's easy to find if when we set up it already, we have omega OA is 12k, right? It's cross product with 0.8j. Okay, so the cross product is what? IJK, right? Is a positive direction, IJK. Okay, if I cross J, we have positive K. If J cross K, it is positive I. If K cross I, is positive j, right? Okay. In the opposite direction, if j cross I, we have the negative k. You're right, according to the right hand rule. Okay, so what does it mean? It means that VA is what? You may starting with 12 multiplied with 0.8 first, that is 9.6. Okay, but k cross j is become negative I, right? Okay, so it's become minus 9.6 I. Okay, so that means that is go to the left because positive I is to the right. Okay, it makes sense, right? Okay, so now we have the velocity VA already, right? At this point. Then now we know already for the motion of crank OA, we already have the information that VA should be over here, right? Then we moving to consider the crank AB. So AB is what? AB is general plane motion, right? For AB is general plane motion. For this problem, we will apply the relative motion analysis to solve the motion of AB. Okay. So for AB, if we consider log AB, so for log AB is what? If we draw the picture, we consider this part. We may draw this part again. Okay. So for this part, we may see that it's maybe something like this. Okay, this point B. Okay, this point A. Now ask ourselves. Now we know the motion at which point? We know the motion at point A, right? We know the motion at point A. So then we have to set up the coordinate at point A. Okay, because we will find the motion at point B relative to point A. Okay, because we know the information at point A. So then let's we set up the coordinate at point A. Next step. Okay, because we know the motion at point A already, right? Okay, so then we set the coordinate over here. We moving the coordinate, moving the reference frame to be to point A, but the coordinate system is also in sequence. It's X, Y, Z also, but we move the point of reference. Just only move the point of reference. Okay, and VA we already know is as like this. We have VA, right? And now we would like to find VB. Okay, we would like to find VB. And we would like to find omega AB. That's actually we don't know, but we assume in this direction because it is in positive direction, right? It is a positive direction, positive in C direction. Okay, if we don't know anything, we may assume the rotation, the omega in positive. It is the recommendation to set up it in positive way. Okay. So according to this, then from the information, we already know the dimension. Okay, this over here is 0.8, right? This is 1. Okay, and this should be 0.6. Okay. Okay, from this, if we would like to find the motion of point B, that is the lot AB is the general plane motion. It is a general plane motion. So then we can find VB is equal to VA. That is the velocity at point A. Okay, if it has the translation only, VA and VB is equivalent. Okay, but it has the rotation also. So what does it mean? It means that point B, it has the motion of the translation, that is VA, plus the rotation. That means that when A is moving already, after that we fix the point of A and then we rotate B with respect to point A. So then it's composed of VB sub A, that is equal to omega AB plus RB sub A. RB sub A is mean that it is the relative position of B with respect to A. Okay, so that means RB sub A is what? Is this vector. This is RB sub A. You all right? Okay. Okay. Then, okay, RB sub A is what? When we set up the reference at point A, so RB sub A is equal to what? From this, we use this information, right? RB sub A is become 0.6 I, right? Minus 0.8 J. You all right? Okay. It's maybe something like this. Okay, this is RB sub A. And then, okay, if we would like to find VB, right? So when we consider B, okay, so you see that, but distance B is what? Distance B is the translation. This translation. So when we set the coordinate like this, x, y. So B is moving up or down. Okay, it's just moving up and down only, right? It cannot move in left and right. It cannot move in x direction. It's moving up and down only. Okay, so then it means that VB has just only one direction, that is VB, the magnitude of VB in J direction only. Okay, it should be in J direction only. VB in this is mean that it is a scalar quantity, it's a magnitude. Okay, it's the magnitude of vector VB. Okay, that we would like to find. So then now we have VB is become VBJ, right? Okay, equal to VA. VA is what? VA is minus 9.6 I, right? Plus omega AB, that we don't know right now. It's become omega ABK. We may define like this. Okay, cross product with RB sub A. RB sub A right now is 0.6 I. Okay, minus 0.8 J, right? Are you all right? Okay. According to this, okay, we have two unknown, right? Now we have VB, we don't know. And we have omega AB, we don't know also. But after you cross product, over here, you have the product of this, okay? That is should be right in the vector form, that is right on the right hand side. It should be in I and in J direction, right? It should be in I and in J. Okay. Okay. And we may compare with the left hand side, that is has just only J. That is actually we may write it is 0 I plus VBJ, right? Okay. If we compare the components of I and J, so it means that we have two equations with two unknown we can solve. Are you all right? And after you solve this equation, you will obtain VB and omega AB. That's all for this problem. Okay.